Okay, so predicates and quantifiers. So a predicate is written as P of X. A predicate can be true or false based on the value of X. For example, we could define our predicate as X is prime. Now, quantifiers, we have the upside down A. This means for all X, P of X. And we have exists X, P of X. This means that there exists an X such that P of X. For all X, P of X is true if P of X is true for all possible values of X, and it's false if P of X is false for at least one of the possible X's. And there exists X such that P of X is true if P of X is true for at least one of the possible X's, and it's false if P of X is false for every possible X. Let's go through an example. So we could have this sentence: all humans are mortal. We are asked to find a statement, a predicate statement for this. We can use the quantifier for all X, and I'm going to use H as my predicate. X implies MX. Here, HX is going to be X is human, and MX is going to be X is mortal. So this works for our sentence here. Basically, for all humans, we must be mortal. Now, how about this one? Some cats are black. So the sum we have to use exists. There exists an X. There exists an X, CX, and BX. So I made this up. CX is going to be X is a cat, and BX, X is black. So it must satisfy, it must be a cat, and it also must be black. And this is for only some of the X's, not all. Now there's two important equivalences that quantifiers have. So not A of X, P of X is equivalent to there exists an X, not P of X, and also not there exists an X, P of X is equivalent to for all X, not P of X. So if we're asked a question So this question is asking, simplify the following so that the quantifiers appear before the nots. So we have to use these equivalences for these questions that are coming up. So first question, not for all x p of x, we have to make sure this quantifier is before this not. We can do this by using this equivalence. So this is equivalent to there exists an x, not p of x. And another question. So this would be equivalent to a of x, a of y, not q of xy. We can simplify this by using the double negation law. Now another one, not exists x, p of x, or e of x for all y, q of xy. We can use De Morgan's law to simplify this more. And now we can do our equivalence operation. So for all x not p of x, and for all x there exists y not q xy. This question says, under the interpretation where x ranges over the positive integers, p of x is 4 divides x, and q of x is odd. State whether each of the following sentences is true or false. So let's do the first one. For all x, p of x. So p of x is 4 divides x. So this is basically saying for all positive integers x, 4 divides x. Now, is this a true or false statement? Are all the positive integers divisible by 4? That's not true, so this is false. Another one. There exists x, p of x, and there exists x, q of x. This is saying, let's think. So there exists a positive integer x such that 4 divides x, and separately it's saying there exists a positive integer x such that x is odd. So this is true. Now how about this one? There exists x, p of x, and q of x. So this is wrapping all of this around in brackets here. Just note these brackets. So this is basically saying there exists a positive integer x such that 4 divides x and x is odd. So this is actually false. since there is so this is false because there is no positive integer that is both divisible by 4 and odd. All numbers that are divisible by 4 are even. That's why this is false. Now, how about this one? For all x, q of x implies not p of x. So this is basically saying for all positive integers x, if x is odd, then x does not divide 4. And this is true, since it's basically just saying that this is not possible. So this is true because if x is odd, how about this one? So for all x not p of x implies q of x. So this is basically saying for all x, for all positive integers x, if 4 does not divide x, then x is odd. This is false, because if so it's false because if 4 does not divide x, x could be an even number that is not divisible by 4. For example, an even number that's not divisible could be 2 or 6 or 10. So yeah.